welcome to another session of Code with me. So, in this particular series, I'm trying to implement a logs interpreter. Um, so, where did we stop last week? Right. So, last week, what we were trying to do was to fix a problem where when you're running this piece of code over here, we realized that our values are not really implemented properly in the sense that um, after we implement the up value, this inner function should be able to capture up these two up values here and these two up values here from the different two enclosing scopes 2 levels away. But the problem is that the code actually returns us for some reason a get global instead, meaning that it wasn't able to resolve the up value variables. And we traced a bit, and the reason why it's not able to return us the up value variable is because the string is different. So basically, we are using intent strings. That means that when we create both strings called A, they should point to the same string, basically the same object. And because this is not the case, when we created the variable A, we use one object, and when we try to search for a value A, we use another string object. And because of that, what we have is we have some piece of code in the table search that says, oh, the string doesn't exist, so I can't find this thing because it's actually matching for the actual object. Then it's like, oh, we never saw this before, must be a global. And therefore, it's returning on the get global variables, get global bytecode. So in this case, we figure out why the strings are being removed. And the strings are being removed in this particular table remove white function, which we implemented for this particular chapter for garbage collection. But so the key here then is realizing why we are removing this and how to fix it. Okay. Let's put on a little bit of background music for the moments of coding where I won't be speaking much. Just a little bit, just the atmosphere. Okay, so before we go on, let's look at the current state of the code. So let me clean up this piece of. Clean this up first. Okay. Memory.c. So here I remove table white, but let's add it back. Okay, so when we add it back, we can see that we can see that we do get an undefined variable here, and if we scroll up a bit, we get all our code. So even in inner, we get the get global, which is wrong. It should be up value. And when we remove this, build and run again, we see that it finally returned 10, which is the value that we have. And more importantly, in our inner function, we actually get the up values from the upper scope, basically. And so let's take a look at why did we even want to. So this is chapter 26 of the book, garbage collection, and in this particular chapter, we have implemented the table remove white, which is a particular piece of code that is used for clearing strings that we are not used. Okay, so we see here that basically the goal of having this function is to kind of sorry, give me a minute. Okay, the point of having this function is so that we can remove strings that are not being used, right? And in this particular case, this vm.strings is a table that points to the user's object string as a key. So let's take a look at our table.c implementation. So it uses object string here as a key, and if the string is not touched in the marking process, right? The string is not touched in the marking process as shown here, then we'll remove it. So let's go back here to see whether our code actually matches that which we are supposed to write. So it's the same here. So if the key is not now, means the key exists as an object string, and the object string is not marked. So key in itself is a entry key. Key itself is an object string, and object string here has this object, and in that we have a variable that says whether it's marked or not, right? Marked or not. So in this case, because our strings are not marked as used, we basically can't. Yeah, basically they are removed. And so let's ask ourselves a question, right? Let's ask ourselves a question. How do we know whether strings are used? How do you know whether strings are used? So if you look at this piece of code here, so putting out the code, closure. How do you know that strings are used? Right. So in this case, we are basically jumping through every single object that is still in the scope. Right, so those strings that are removed here are basically object strings that point to the name of the variables that are still in scope at that point of time, or in the above scope. So let's check that out. How do we mark things as? So let's check the marking process, right? So we mark up values, but at this point of time, they're not up values yet, right? They are just normal. Right, function strings. Right, is the up value? We are marking them up. Right. Okay, so let's look at the code that we have now. Memory.save. value just mark value, right? So when you try to mark an object, you're also kind of marking the name of the object, right? What's going on here? These two, we don't need to mark anything. Right. So let's ask ourselves. At this point of time when I'm in need, what is the thing that points to this variable token B being used? Right. So what is the thing that points to B in use? So to go through that, we have to look at local resolve our function and see that the compiler scope basically has this search object table tells us whether, so if you look at search, if we look at search, we see that it tries to go through all the list of items. So in this case, what we are basically missing, so before we sweep, right, so we need to mark roots, trace references. What does trace references do? No, that's not enough. We need to mark roots. Okay, so what are the things to mark, right? So we have global names, global values. Oh, we need to mark global values as well. The table, mark array. Okay. Anyways, so there was a fix that we had previously, so I'm putting that back in. I kind of lost the code when I was trying to clean up the Git mess I have here. But anyways, okay, what are we looking for? We are looking to we are looking to mark even more objects here, and basically the things that we are trying to mark is the strings that are being used as variable name tokens, and that is likely in the frame count, right? vm.frames. So let's look at vm.frames to see vm.c frame count h frames core frame. Is that the core frame? Actually, that's an easier way, right? Let's see where they actually try to mark closure. Yes. So table search is in the compiler. And the compiler has enclosing. So I need to in the compiler, do I mark any compiler here? So I have to check out what is in the core frame. Okay, I do have closure, but that's not what gives me I don't actually store the compiler. Don't have a. Do I have a globe? Okay, so the problem is right now we have a on runtime. On runtime we have a global VM that we can call to make sure that all our core frames are in place and marked. But we don't really have a compiler that is global. Everything is kept in place here, and the search is actually in the compiler itself. So how then, okay, what do we need to expose to make sure that the memory GC still works in the compiler scope, right? What we need to do is to make sure that we somehow have access to current. And what's current? Current is not really anyway. So we actually we don't really implement. We have a mark compiler routes, right? That's how we keep it hidden. Okay, we do have a mark compiler routes. Let's look at mark compiler routes. Okay, it should have, right. So in the compiler routes, we go through the enclosing and things like that. Okay, so this is good. So in my mark compiler route, I can find mark as the function. So it's in the compiler. That's the function. And the table search and locals. Right. Okay. Local. Okay. I don't need this because what is this used for? Is captured. Right. Yeah. Let's put a note here. Local is currently used for up value is okay. A note here. We don't really need to fully understand this tool for it to work, but I said as long as we make sure that, because none of these are really objects, so they'll be fine. I just need to make sure that table search. Right. So let's check it out to see whether we did write something for table. We did. Okay, so we do have a mark table. And mark table basically goes through every item. And to get the entry, and I should be fixing this. If entry key equals to null, continue. And if okay, entries. So if this is null, I just go ahead and do nothing. Okay, actually a mark value if it's a string or so no objects. Okay, I see. We don't need to be very clear. Let's do it. Let's do it. Mark table. Okay, so here we will also need to mark table. Right. Okay, so before we do that, okay. For that, the code that we are generating is in. Okay. Let's go here. Entry key. No, continue. In. Okay. Do that. And run this. Okay, 10, which is correct since I need to remove. Huh. No, to get. So I fail. Oh, some of them passed. Okay, for some reason, I lose. Okay, so in inner, what we realize is that op A, op B, op A, op B, I basically only kept half the variables. Yeah, I basically only kept half the variables. Huh, that's strange. But let's go through. Let me think. Okay. That's strange. Okay. Let's copy this. Okay. And after adding compiler.search, we still missing half the variables. Okay. What's wrong here? And how do we find out? Okay. So looking back at the code that we have there, we check a few things, right? Can you check a few things? They do a mark compiler road. I want to know that. Jesus. How about I yeah, yeah. I let's break on this, right? Yes. So why am I breaking on it? Because I want to know whether the things that I want to be there is removed. And to do that, let's do a point. Run my test. Doesn't matter. Basically, I just remove one line of new line. Okay. Right. And I want to print compiler. Function. Name, okay. Compiler. Name. Okay. It does have okay. Oh, it does have. And the name is none. Okay, the name is nothing. Okay. Let's continue. Let's try this again. Name is still nothing. Nothing. Oh, outer. Okay. Right. That's the scope that I want to be, right? Outer. That's the scope I want to be. Okay. So I wanna do my search for entries. Okay. It's very I know. And okay, one check. Okay, why is only removing one? Let's just okay. 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 Definitely in this particular scope, you wouldn't have it. Current is particular scope, which is correct. Using this, I should have a this I should have E and D. Oh, this I should have C and D, but let's check whether I'm correct. Okay, in count I have 3, why 3? Because C and D and internal entries. Okay. Okay, 2. The C and D, so it should be able to get it. But now it's A, so let's go for a bit more. B. Okay, let's still check. C is still there. Okay. Check. C is still there. And okay, so this time we should be looking for C now. This time we should be looking for C now. And according to our bytecode, this C should fail. So okay, let's go into the function of local. So this of course will fail. Let's just next. Fails. And our 896. Oh, wait a minute. Local. C is right. So it will try to resolve up value, and I can see that this is not true, and this should return so here we see resolve local being caught, and if I check this scope, I should be in the meet function. In the meet function here, and in we have meet function here, right? I will resolve local now. And basically my compiler.search 2 should still give me key just C. Right. And this key is basically this key here. Key of C in search. Let's paste the whole thing. No, this two. Okay. It is in the scope of C, and I'm going to print this out. In here. Okay. Okay, so I basically prove that it's the same. And now when I do table get, it should resolve correctly. So I try to do step in. Strings, okay, token string, okay. Thanks. So resolve local. For some reason didn't manage to get to return -1. So this failed, right? But this is this. Why is it not using the one that we already have? The same. That we already have. So let's print out what this value holds. It's C. Hash is this. So value is correct. And for some reason it's marked here is 11. But, okay, anyways. What is it doing, right? Anyways. The hash is the same. So the hash is the same. Let's look at vm.strings. No. Will be vm.strings. It will be online. It's 11. For some reason, it's 11. This is 11. Okay, so let's go 11. 11 plus in if is not is marked 11, basically means that the last value, what? It's a 1 by 100. Let's try to print that again. You guys mark 11. Okay. Type. Huh. So we see that this particular entry is see that this is corrupted. Okay, so we see that data is corrupted, so it may or may not be removed. It doesn't even recognize. So how do we do this? How do we do this? How do we do this? But for some reason, this is fine. So somehow only first variable out of the two vars is. So to make sure that I remove all silly willies, we go and use back or reallocate here. And we build it. And we try it out. Ref and same, right? Same case. So we have come to the point of realization that so I guess this is kind of the end of this particular session. So let's do a roundup of what we discovered along the way. So when we started off, we are trying to find out what is going on in the code which caused us to return get applicable on supposedly up value code or up value variables. And we found that it's because we accidentally removed them from the hash table. We accidentally removed them from a table. So we added code to mark those tables as used. And but in doing so, we still are missing some variables such as, so in this particular case, AB we missed out A, CD we somehow missed out C. Those are still variables for some reason. And from what we have looked at in the GDB, looks like the point of us trying to resolve those values, the entries for C looks corrupted, D looks fine. So there's something weird going on there. We need to figure out what. So so in this case, we have adding what they do here. So we added added compiler.search to mark compiler roots. So we added compiler.search to mark compiler roots. Right. And then we realize that data for vm.strings look corrupted. Okay, so that's it for this particular session. Thank you guys for hanging out with me, watching me code. See you in the next one.